Hi, this is the video to prepare for the next exercise in the differentiation chapter. We're looking at Year 2 maths, and we're going towards exercise 9C. What I'll do is I'll just work through the examples, and then you can have a go at the exercise and you can let me know if you have any questions. So the chain rule is a pretty key tool that we use for differentiation, and it's really this: we can treat derivatives as fractions. Now they're not fractions, but for this purpose they behave just like fractions. We can see that dy over dx is dy over du times du over dx. The du's cancel out, if you like, and that's useful because what I can say is use the chain rule to differentiate y equals 3x to the 4 plus x to the 5. Now I've got a few choices here. I could expand this using the binomial expansion, but I don't need to. What I'm going to say is let this thing u be the expression in the bracket, and therefore y equals u to the 5. Well, clearly dy du is 5u to the 4, and we actually want dy dx, so dy dx is dy du, which I've got, times by du dx. Well, du dx is just the derivative of this expression with respect to x, so dy du 5u to the 4 times by du dx, differentiate this, 12x cubed plus 1. We know u is 3x to the 4 plus x, so it's 5 lots of 3x to the 4 plus x to the 4, and then I multiply it by 12x cubed plus 1. And I'm not going to expand it, I haven't been asked to expand it, so that's my answer. So that's all the chain rule is. The chain rule says if I have an expression to a power, differentiate the whole thing. You know, what I've done is I've brought the power down, reduced the power, there it is, and then multiply by the derivative of the bracket. And that's a better way to think of it as thinking of the fraction. Differentiate the whole thing as if it were one term, and then multiply that by the derivative of the bracket. And then all we've got to think about is what to make my u into. So there's example 6. Example 7 y equals sine to the 4x. Now there's a little notation point here. We need to understand that sine to the 4 of x actually means sine x all to the 4, and if it helps, write it like that. So differentiate the whole thing. Dy dx is, bring the power down, 4 sine x cubed, multiplied by the derivative of the bracket. Remember, sine x differentiates to cos x. 4 sine x cubed cos x. Okay, let's do example 8. Y is the square root of 5x squared plus 1. Well, that's 5x squared plus 1 to the half. So dy dx, differentiate the whole bracket, half times 5x squared plus 1 to the minus a half, multiplied by the derivative of the bracket, which will just be 10x. And we'll just tidy that up because, of course, a half of 10x is 5x. So 5x squared plus 1. The question actually gives us a value of x dy dx when x equals 4. Oh, where's my calculator? There it is. Remember, the calc button is your friend. 5x times by 5x squared plus 1. Oops. Plus 1 to the power. Got to put it in. Minus a half. X is 4. 20 over 9. Now remember, because I've got a value for x, I could actually check this on my calculator. I could differentiate, put in my original function, the square root of 5x squared plus 1, when x equals 4. 20 over 9. Good. Okay, and example 9. So example 9 is an interesting one. Remember that we can, in certain circumstances, treat this derivative thing as a fraction. So if I can work out dx dy, dy dx is just the reciprocal of that. And that's what example 9 is intended to show us. Y cubed plus y equals x. Well, it's actually easier, rather than make y the subject and then differentiate, it's easier here to find dx dy. Dx dy is 3y squared plus 1. So, of course, dy dx is 1 over 3y squared plus 1. Now, this is odd because we're used to an expression in x and then we sub in the x value. But this is fine because we actually have the y value, so we can sub it in. So dy dx when y equals, question gives me 1. Well, that's 1 over 3 plus 1, a quarter. Now, I can't actually test this on my calculator because this expression needs to be in terms of x, and I have to input a value of x. So this is a difficult one. I guess I could try to rearrange it on my calculator, make y the subject, but it's actually not that easy to do, and I think not worth doing the time it would take. Okay, so we should now be able to have a go at exercise 9C. Let me know if you need anything, and I'll see you next time. I just wanted to do a little add-on, just show you a couple of examples that might trip you up. This one isn't in the book, but let's go for something like sine to the 5 of 4x. Well, that's sine of 4x to the 5. Now, if we think about the derivative of sine to the 4x, well, we have looked at this before, but the chain rule is why this is true. Let's say y equals sine to the 4x. We'll call that sine to the u, where u is 4x. So du dx is 4, and dy du sine differentiates to cos u. So dy dx then is dy du cos of 4x times by 4, or 4 cos 4x. Now, this is not a new result. We have seen this before when we looked at the trig, but the chain rule is why this is a result. So I've got, if you like, I've got a double chain rule to do here. What I've done to prepare for it is I've differentiated sine 4x, guess 4 cos 4x, and now I'm going to say chain rule again, differentiate the whole thing, so bring the 5 down, reduce the power, 5 times sine of 4x to the 4 multiplied by the derivative, which I use the chain rule for here, multiplied by 4 cos 4x. So 5 lots of something times 4 lots of something else, 20 sine 4x to the 4 cos 4x. So just be aware, and I'm looking at question, what am I looking at? I'm looking at question 11. You need to do this, if you like, double chain rule. And e to the, I don't know, 2x plus 1 cubed. Double chain rule here again. Differentiate the whole thing. Remember, e to the x, the derivative of e to the x is e to the x. So it's going to be differentiate the whole thing, e to the 2x plus 1 cubed, and then multiply by, this would be my u. So multiplied by, and this would be the chain rule. 3 2x plus 1 squared times by 2. I suppose I could have done it on its own here. I could have just done a little sidewards working out. dy dx is, bring the 3 down, 2x plus 1 squared multiplied by the derivative of the bracket. So 6 times 2x plus 1 squared e to the 2x plus 1 cubed. And I'm not going to bother expanding this bracket. So as I say, when we get to question 11, chain rule within a chain rule. Okay, enjoy.